Hi, Bianca here. So we already recorded the first part of finding the trig ratios in quadrant 1. Today we're going to work on quadrant number 2, 3, as well as 4. But before we get started on finding out what the trig ratios are in each quadrant, we need to know what the triangles in each quadrant look like. So we're going to start by sketching those out. So if we look at quadrant 1 triangle like we did in the previous video, remember it always comes out from the origin into the quadrant and then drop it down to your x-axis. That creates your 90-degree angle there, and then you label this angle right there as your theta, so that would be your reference angle. So that's a quadrant 1 triangle. But what if we move into a different quadrant? So let's look at something in quadrant 2. So you start off the same way, from the origin, out into the quadrant, and then down to your x-axis. So creating your 90-degree or right angle right there, and then labeling this as your theta. So this would be your quadrant 2 triangle. Moving on to quadrant 3, we go ahead over here, and now we're on the bottom, right? So if we're in quadrant 3, we're over here. So starting at the origin, drop it down into the quadrant, and instead of going down to your x-axis, because you notice your x-axis is now above, you're going to swoop it up. So this is your 90-degree angle there, and then this is our theta. So that is our reference angle. So that's quadrant number 3. And then over here we have quadrant 4. So I'm just going to come on this side. Quadrant 4 is here into the quadrant, up to the x-axis, creating your 90-degree angle, and then this is your theta. So you've got quadrant 1, 2, 3, and 4. So those are what your triangles would look like. Okay, so if we think about the triangles in each one of our quadrants, a lot of times we like to remember it as the Bowtie Method. So let's look at it all on one coordinate plane so we can see why that is. So our quadrant 1 triangle, just sketching that out, we've got this. Quadrant 2 into the quadrant and down, we've got this, right? So starting to form that bow tie or half of it in reality, looking at quadrant number 3 into the quadrant and up to the x-axis this time, and then lastly quadrant 4. So you can see how it kind of looks like the bow tie. So we call it the bow tie method just to kind of see how you should draw your triangles in each one of your quadrants. All right, so now let's talk about the different signs in each quadrant. So we know we have quadrants 1, 2, 3, and 4. So I'm just going to kind of sketch that out here. And we need to figure out what trig values are positive or negative in each quadrant. So now normally when we're talking about the coordinate plane, our coordinates are always x, comma, y. But now we're in trig world, and instead of x, y, we now have cosine, comma, sine. Okay, so the x value is really your cosine, the y value is really your sine. So if we're talking about the different signs, positive or negative in each quadrant, we use a setting. A lot of times it's all students take calculus, but I like to use all-star trig class since we're talking about trigonometry. So I'm going to just sketch out those letters here. A, S, T, C. All-star trig class. And let's talk about what that means. A stands for all, right? And that means that all your trig functions, all 6 of them, are going to be positive in your first quadrant. Moving over to quadrant number 2, it starts with an S. Well, that just means that our trig function, sine, right, starts with an S, sine, and its reciprocal function, so the reciprocal of sine is cosecant, those are both going to be positive in quadrant number 2. Everything else is going to be negative in that quadrant. Looking at quadrant number 3, it starts with a T, so that means that our tan function, as well as its reciprocal, so that would be cotan, is going to be positive in quadrant number 3, and everything else is going to be negative. And then lastly, in quadrant number 4, it starts off with a C. So we have our cosine as well as its reciprocal function, which is secant, and those are going to be positive in that quadrant. Okay, so this kind of also makes sense if you think about it. We went over to the right-hand side for quadrant number 1, which is in the positive direction, up, which is also positive, so that would be Y. It would be a positive trig value there. Here, if you think about it, you're going to the left, which is negative, and then you're going up, which is positive. So really, if we're talking about our x values is cosine. So if I went to the left negative, right, it can't be positive, so that makes sense. Also think about tangent. Something we like to remember about tangent, in order to get tan is really sine divided by cosine. So if I'm looking at this quadrant over here, we take our sine value, we divide it by our cosine value, and then we would get our tangent. All right? Okay, so let's start with the first example. So So here we're given sine of b is equal to 5/8, and they're telling us that it's in quadrant number 2. So I'm going to go ahead and sketch out a quadrant 2 triangle. So remember, into the quadrant, down to the x-axis, there's your 90-degree angle, and this is the theta that we're referring to, and in this case, it's sine of b. So if you think about sine, sine is so. That's S-O-H. So we know that it's opposite over hypotenuse. So the opposite piece is up here and the hypotenuse is here. So let's label the triangle as such. So opposite that angle, if you can draw that dotted line across, right, is 5, and then the hypotenuse there is 8. So we have 5 and 8, but we do need this missing link because the whole point of this is we want to find all 6 trig functions, or trig ratios. So we need to do Pythagorean Theorem in order to find that missing piece. So we've got 5 squared plus b squared is equal to 8 squared. So we know it's 25. And then 64. Subtracting that out, b squared, 25, we've got 39, and then taking the square root there, we know b is the square root of 39, which we cannot simplify. Okay, so you can't break down the square root of 39, 3 times 13, we know none of them are perfect squares, so you leave as is. So we've got rad 39, so I'm going to label that over here, rad 39, that's the length of that side. So we know that we're going to label this triangle OH and A so that we can set up our trig ratios. We've got O, H, and A there. All right, so we want all 6 trig ratios. So the first we're going to start off with the sine. And the sine of B, it was obviously given, so that's 5/8. So nothing really need to do here. But we can get the reciprocal function right away. We know the reciprocal of sine of B is cosecant of angle B. And that's just flipping that upside down. We've got 8 over 5. But there's one thing that we have not taken into account just yet. We have to think about what sign, meaning positive or negative, each trig ratio is in the quadrant. So we're going to go back to our all-star trig class. A, S, T, C. So we're in our S quadrant, which means that sine and this reciprocal are positive, but everything else must be negative. So we're good there, right? Positive, so we don't need to change anything. So let's keep moving. We now have our cosine. Cosine, remember, is the c piece. That's A over H. The adjacent piece here is rad 39, and that's all over the hypotenuse, which is 8. Now, remember, we are in our second quadrant, which is our S quadrant, and that means that that is positive, so cosine must be the opposite, which is negative, right? So now we've got our reciprocal, which is secant, and B, theta, whatever. Flipping that upside down, we've got 8 over rad 39, and remember that's negative. But you do have to rationalize that, right? Because you're not allowed to have a radical in the denominator. So you're going to multiply by rad 39 over rad 39. I'm just going to do it on the bottom because I ran out of space there, so I'm just moving that over here. Secant of B is equal to negative 8 rad 39 all over 39 when you rationalize that. The next trig function would be our tangent. So setting up tan of B, that's TOA, so opposite over adjacent. So the opposite piece here is 5 over the adjacent piece, which is rad 39. And then once again, remember, it has to be negative in that quadrant because only sine and its reciprocal are positive. We do have to rationalize that piece one more time over here. So I'm just going to finalize the answer. I'm not going to show the in-between steps because I'm assuming you know how to do that at this point. Negative 5 rad 39 all over 39. And then lastly, we just have the reciprocal of tan, which is our cotan of B. And I don't recommend flipping these rationalized version because then you notice that that radical would just move into the denominator and you're going to have to rationalize again. So I always just say a rationalize, or look at the non-rationalized one, the original, and flip that upside down. So flipping that one as its reciprocal there, we've got negative rad 39 all over 5. All right, so here's the last example in a different quadrant. So this time we've got quadrant 3. So I'm going to go ahead and sketch out a quadrant 3 triangle quickly here. We are down here into the quadrant, up to the x-axis, angle, and theta. So this time we have cotan, and cotan we remember is the reciprocal of tan, so TOA. But instead of O over A, it's really A over O. So I'm just going to label that here, A and O. So the adjacent side of this triangle here is 7, and the opposite is 3. So we do need to look for the missing length because once again we're going to be setting up the trig ratios for all of the trig functions. So we need Pythagorean Theorem. So you've got 7 squared plus 3 squared is equal to c squared. This time we're solving for the hypotenuse. So 49 plus 9, we've got 58. And taking the square root, c is rad 58. So we're going to label that over here. The square root of 58 is the length of the hypotenuse. Also remember, we are in quadrant 3, so we have to remember our all-star trig class. So T quadrant this time, which means tan and cotan are positive, everything else is negative. So let's start setting up our trig ratios. So first we want sine. So the sine of the angle in this case, it's b. We could label this as b if we need. We know it's opposite over hypotenuse. The opposite here is 3. The hypotenuse is rad 58. Once again, rationalizing that, but also remember it must be negative because you're in your T quadrant. So if we were to rationalize that, we've got negative 3 rad 58 all over 58. The reciprocal of sine is cosecant. So we're going to flip that again, but remember we don't want to flip the rationalized fraction. You want to flip always the original. So in this case, we've got negative rad 58 all over 3. We then have our cosine. Cosine is ca, adjacent over hypotenuse. The adjacent side here is 7 all over the hypotenuse, which is rad 58. Once again, remembering that this must be negative because you're in your T quadrant, and then rationalizing that again. So we've got negative 7 rad 58 all over 58. We've got the reciprocal of cosine, which is secant. So flipping that upside down, remember the original. So negative rad 58 over 7. And then lastly, we've got our tan and cotan. So tan, remember, is toa, opposite over adjacent. The opposite is 3 all over the adjacent, which is 7. And remember, this is positive because you're in your T quadrant. But also remember, we were given the cotangent. So the cotangent was 7/3. You could have just flipped that upside down. So I'm just going to rewrite that over here. Cotan is 7/3. And that's it. That's how you find the trig ratios in each of your quadrants.